Okay, so I did this question twice so far, and once the audio didn't come up, and the second time the video just didn't come up at all. I'm not sure what happened, but I'll go ahead and explain what I did. So here we have a power series, and the question asks to prove that this on the left-hand side, the sum of both of these power series is equivalent to one power series on the right-hand side plus some coefficient A. So what I did is I started working on the left-hand side of the equation, and on the most left series, what I did is I evaluated that series at k equals 0, so that gave me a1x to the 0 plus the rest of that series now starts from k equal 1 to infinity, because I've already taken out the term that the first term of the series. Now, for the second series, what I did is I shifted the index of the power. So I said I'm going to let k plus 1 equal some integer n, which makes k be n minus 1. And I went into the series, and wherever there's a k, I replaced that with n minus 1. So k plus 1 became x to the k plus 1 became x to the n. A's of k became a's of n minus 1. And k equals 0 now becomes n minus 1 equals 0, which means the series now, as I've indicated here, starts at n equals 1, which is very convenient because it starts at the same place that the other series start at, so that way I can combine the two series together. Equivalently convenient is the fact that both of the x's now have the same power, because this green series is the same thing as saying n is a dummy variable, so I can just take it out and replace it with another k. So now I have another series starting at 1 going to infinity of a of k minus 1 x to the k, which is equivalent to this one right here, ak plus 1 x to the k, starting at 1 go to infinity, aside from the fact that they have different coefficients, but other than that they start at the same k and they both have the factor of x to the k. And by doing so, this now enables me to combine both of these series together where I have the check marks, and so now I have them under the same summation, both starting at k equals 1 infinity, in addition to the a1 x to the 0, which became a to the 1. And now if I factor x to the k out of both of these, because they both have x to the k, I get the sum of the two coefficients, a of k plus 1 plus a to the k minus 1 times x to the k, summation starting at 1 going to infinity, which is exactly identical to the right-hand side of the equation I'm trying to satisfy. So this proves it, and this is just a way of how to manipulate and shift the index in order to combine two different series that may start at different places and at the same time have a common term or common power term, x to the k, applied to both of them. And this will become relevant in later videos when I solve differential equations based on series solutions. This would enable you to figure out the coefficients much more conveniently and much easier. Okay, thanks for watching. Please don't forget to comment, subscribe, and like. With your support, I know I will be able to expand this channel to unlimited limits in terms of unleashing this academic side and posting as much material, as much explanation, as much topics as I can on the subject of mathematics and physics. Thank you.